All right, so for this video, I'd like to go over the Sgarbossa criteria and its application to left bundle branch blocks and paced rhythms. So in order for us to use the Sgarbossa criteria, we need to first identify a left bundle branch block, and we're going to quickly go over how to do that. This 12 lead ECG right here is an example of what a normal left bundle branch block should look like. As you can see, the axis is a left axis, and we can determine that because in lead one, we have a positive deflection over the isoelectric line, and then in lead ABF, we have a negative deflection over the isoelectric line. And so this gives us the left axis shift. Furthermore, if we move over to the precordial leads, you'll notice that we have a wide complex QRS, and if we zoom in there, it looks like it's probably about greater than 120 milliseconds, and so that constitutes as a wide QRS. And then something that's very specific for the left bundle branch block, again, is going to be poor R wave progression. And as you can see here, we've got these little bitty R waves that are not transitioning in V3 where they normally should. In fact, our transition lead seems to be V6, or excuse me, V5, and even at V5, it really is kind of a wimpy transition. All right, so one hallmark of the left bundle branch block, and the one thing that normally gets people into trouble when it comes to trying to identify ACS, is the fact that the morphology of the QRS complexes in relationship to the T waves is going to have something called discordance, meaning that when you have a positive QRS complex, the T wave is generally going to be negative as it pertains to the isoelectric line. We see this in V1 where we have a negative QRS complex, and then we have a positive T wave and ST segment. And this is kind of problematic because when you have this type of discordant activity, the abnormal depolarization phase affects the repolarization phase in a manner where it does create some degree of ST elevation. If we zoom into lead V1 here, for instance, we'll see that the J point, which is like right here, is isolated, or excuse me, is elevated above where the PR interval is and where the TP interval is. And so based off the conventional STEMI criteria, if we were to take this ST segment and compare it to the ST segment in the same contiguous lead, that being V2, we would notice that this would fulfill ST elevation criteria for STEMI purely because we do have this elevation, which does appear to be about 2 millimeters, millimeter and a half above the isoelectric line. And then the fact that it is in V2 also would fulfill STEMI criteria because if you remember, V1 and V2 are considered to be contiguous with one another. This is what gets people into trouble because, and this is what is responsible for a large amount of like false cath lab activations, is because people misinterpret this normal variant for being something of acute onset and STEMI onset. So, in order to counteract this, we have, or rather, Dr. I think Sgarbossa has come up with a set of criteria to use in the setting of both left bundle branch block rhythms, such as this one, and ventricular paced rhythms, which oftentimes have a very similar morphology to the left bundle branch block, to kind of identify people who are experiencing acute coronary syndrome who have these types of dysrhythmias, which would otherwise make interpretation for ischemia pretty difficult. And so when it comes to the Sgarbossa criteria, there's three of them. We're going to focus on the first two because they are the most sensitive, and we'll start with criteria number one. So criteria number one is looking for something called concordant ST elevation greater than or equal to 1 millimeter. Oops. And it only has to be in one lead. So what this means is that as opposed to this discordant behavior, or not really behavior, but this discordant appearance that you're seeing here, where you have like, say, right, this AVL lead, positive QRS complex, and then a negative T wave, you are looking for the presence of concordant ST elevation. And what that might look like, particularly if we're focusing in on what AVL would be something like this, where you have this big QRS complex, and then it terminates into this T wave, which is found to be above the isoelectric line, but heading in the same direction as the QRS complex. And so that's what concordance means, or concordant ST elevation means in this particular criteria. So the beauty of this particular criteria, the Sgarbossa like 1 criteria, is that you only need this concordant ST elevation to be found in one lead. And the moment you find it in one lead, it could be 4, B4, B5, B6, it could even be ABF, then you're done. Then that is positive for Sgarbossa criteria, and that person has a STEMI until proven otherwise. And the other beautiful thing about this concordant ST elevation that is, if it is present, it is the most specific for MI. Now, the second one is going to be concordant again. Let's see, hopefully I can spell this correctly. It just dawned on me that I forgot a R right here. It is concordant ST depression. And this is a little bit different than the original concordant ST elevation in that with the concordant ST depression, we're only looking for this in V1 through V3. And with the concordant ST depression criteria, it's still similar in the sense that you're looking for the orientation of the QRS complex and the orientation of the ST segment. However, in like this particular case, you'll have, generally speaking, or really always speaking in the setting of left bundle branch block, you'll have a tiny R wave, deep QRS complex, and a negative deflection, and then you'll have some ST depression terminating into a T wave below the isoelectric line. So that would be your depression. And so in order for the Sgarbossa 2 criteria to be fulfilled, you would need to have this concordant, again, that's the key word here, ST depression in leads V1, V2, and V3. Or I should say, ideally in either V1, V2, V3. And similar to that of the concordant ST elevation, you only need it in one lead. And the same criteria apply. So it would be also greater than equal to 1 millimeter ST depression. All right, so with these two criteria in mind, we'll give the third criteria just a little shout out, even though it is the least sensitive of all the Sgarbossa criteria. And the third one is the ST elevation, so this right here, of the discordant QRS complex and ST segment, so this whole shebang, is greater than or equal to 25% of the QRS complex. So that is to say um, that the distance of the ST segment, so from the isoelectric line, or really from the J point down to the isoelectric line, is greater than or equal to 25% of the overall QRS complex. It's pretty interesting in most examples that do look at Sgarbossa criteria. You oftentimes see either the first criteria or the second criteria, and then a lot of times the third criteria you'll see in conjunction with one of these or both of these, but it's kind of difficult to find examples where the 25% or greater Sgarbossa criteria is the sole finding in the ECG. So let's look at a couple of examples. All right, so this first example, we have a left bundle branch block. There's a wide complex QRS. It looks to be greater than 120 milliseconds. And then we notice too that there's very poor R wave progression. Again, the transition point doesn't even occur until lead 5. And then we also have this kind of like rabbit ear looking thing here too, which is another indication that you might be dealing with the left bundle branch block. Interestingly enough, though, if we look at the rhythm strip, and I know this is not a rhythm strip tutorial video, but I feel like this is worth pointing out. You'll see that there is electrocardiographic polyuria, where you have too many P waves, and one P wave in particular not generating the QRS complex. And so this person, just based off of seemingly random-ish, or yeah, so this person based off of the like the couplets that we see here of QRS complexes, and then the non-conducting P wave probably has a second degree type 1 heart block. But moving back to what we were discussing earlier as far as Sgarbossa criteria. So we've established this person has a left bundle branch block. We've identified that it is in fact a left bundle branch block based off of their criteria for ruling that in. Now it's time for us to apply the Sgarbossa criteria. And so if we scrutinize the leads looking for like the first Sgarbossa criteria, which is concordant ST elevation, we really don't have to look very far. If we look at lead 2 over here and zoom in on these QRS complexes, we can see that we have a positive QRS complex followed by a positive T wave, and it appears that there is some, albeit a little small, elevation of that ST segment from the isoelectric line. And that looks to be maybe about a millimeter. It might be only a half a millimeter. The paper quality is not that great, but if we look at lead 3, we can now really appreciate that there is some pretty distinct elevation off of the isoelectric line. And so based off of this finding, and even in ABF, we can very clearly determine that, or clearly determine that this is in fact a positive Sgarbossa criteria, and this person is probably experiencing an MI until proven otherwise. All right, let's look at example number 2. So example number 2 is interesting, and it shows that you can in fact discover ACS in the setting of a paced rhythm. Oftentimes, people will say that you can't identify ACS in the setting of a paced rhythm just because the pacer, and you can see the pacing spikes here, the way that it depolarizes the myocardium is such that it does not allow for the normal pathways to occur, and as a result, you get that abnormal discordant repolarization phase. However, in the setting of a paced rhythm, you still can apply Sgarbossa criteria. In fact, all 3 of the criteria to it. And if we take a look and try to apply Sgarbossa 1 criteria looking for concordant ST elevation, well, we're not really finding anything. This looks to be kind of discordant. This looks to be discordant. This is discordant. Yeah, a lot of discordance, not a lot of ST elevation that we would determine as being concordant. So let's take a look at Sgarbossa 2. So Sgarbossa 2, remember, is V1 through V3 ST depression concordance. And if we use that definition and apply it to both V1, V2, and V3, we'll discover that we do have positive Sgarbossa 2 criteria in both V2 and V3. And so if I blow this up, we'll see that the pacer spike is here. This is the beginning of the R wave here, and we've got an S wave here. And because we have the predominant amount of electrical flow going in a negative direction, and we have the predominant ST depression, so away from the isoelectric line, going also in the negative direction, this would be positive for ST depression concordance. And so as a result, this would be an MI until proven otherwise.